Welcome to physics class, and today we'll be having nuclear energy part 1. And remember, we have done series of radioactivity, but this nuclear energy is where we are going to be looking into fission and fission. Now, by the end of this lesson, you should be able to explain transformation of elements, discuss nuclear reaction, and then give also a better explanation of fission and fusion and nuclear energy, explain the application of radioactivity, evaluate Nigerian nuclear energy program. If you are ready, let's get started. Transformation of elements is the process in which a nucleus undergoes spontaneous change into one or more different nuclei with the emission of radiation, loses of electron, or undergoes fission or fusion. The type of transformation depends on whether the radioactivity is natural or artificial. Like I said before, I said if you have gone through this series of this lesson on radioactivity, you will understand better and appreciate this topic, because fusion cannot do without this radioactivity, which is called the spontaneous disintegration of the nucleus of an atom, with emission of either alpha or beta, or both of them, or more of even the gamma rays, with the release of energy. Then the harnessing of whatever this energy comes out with is what this topic is going to look into. Because nuclear energy is just using what happens with radioactivity to produce and to build energy. And that's why we are looking at, every country has their own energy program, harnessing nuclear energy. Sometimes people look at, whenever you talk about nuclear energy, people go into war, but there are many advantages of nuclear energy, which we'll be looking at before the end of this lesson. Now, the natural spontaneous breakdown or disintegration of an unstable nucleus of an atom, during which alpha or beta or gamma is reduced, is what natural radioactivity is. Now, natural radioactivity include, look at this radium-226 decays to radium-222 by the emission of alpha. Let's look at how that is done. If you have this radium, let me use R sub A with 222, 226, right? Now, if this with a given atomic number, now, if this atomic number is, let's call it X, then decays, when it gives out, it's giving out an alpha particle. So the alpha particle is going to be given out is given as 4,2, which is a helium atom. We have 88, which is the atomic number of this atom. So when it gives this, then we are going to have a new element that will be formed, and which is random. And this is going to be 2, because 226 minus this 4 is going to be 222, while 88 minus 6 is going to be 86. So this is the new element that was formed as a result of this natural radioactivity. So this is done spontaneously with the helium atom. All right? So, which is also there. And remember, in our definition of radioactivity, we say there must be a release of energy. The energy must be released on the process. Then if you look at this number 2 as well, we have random, which is 22, and we have this 222, 86. When it gives off 2 alpha particles, no, this is 2 beta particles, we have 2. Now, because of these 2, the values of this will be changed, and this is going to be plus. What is going to be forming? Remember, there must be a release of energy on the process. Now, whenever beta particle is involved in a reaction, the atomic mass does not change. So the 222 is also going to be produced, and I will be telling you what happens and what this has led to. Then we also have this. Remember, this is minus 2. So 86, because this is minus 1 times 2, because it occurs 2 times. So we are going to minus 1 and minus another 1. So 86 minus 2 is going to be giving you 84. All right? Remember, this is beta, it's not alpha. We are going to do the little mathematics about it. So there is a new element that is formed. It's also going to be this random, because it must be an isotope, random. But what are we going to put here? We have to be careful, because remember, this is beta and it's no longer alpha. So what I'm going to do is, all the atomic number on the left-hand side must balance the atomic number on the right-hand side, and then plus the release of energy. So let me call this place X until I find what it is, then I will put it. So I have 86 is going to be equal to, this is equality sign. This separates the left-hand side of this reaction from the left-hand side. This is the right-hand side, and this is the left-hand side. Now this is minus 1 times 2, which is minus 2 plus what? I'm looking for what to put here, remember. So this will go in here. I'm going to add 2 to both sides of this equation. Minus 2, we cancel this minus 2. We are going to have this plus is going to be 88 is equal to X. Therefore, the atomic number of the new element formed is going to be what? 88. And this proof makes true the theory which says that whenever beta particle is given off, a new element form increases in its atomic number. So it was 86 here, because beta particle was given off, then the number of atom has increased to a new one, and this is called the isotope. Remember, isotope must have the same number of atomic mass, but different atomic number. So this is an isotope of random, which is also what happens to this kind of natural radioactivity. We are still explaining this. I'm going to explain finally what this is. So this is the idea of this nuclear energy. In this one, this is uranium 238. So uranium 238 with atomic number 92. Remember, uranium is an isotope, so it has we have different kinds of uranium, and it gives off 2 alpha particles. Plus, what is going to happen? This one is quite direct. Okay, no, plus it's also giving another beta. After giving out 2 alpha particles, it also gives 2 beta particles. So what will be happening? We are going to find out what will be happening. So this is going to be 2 minus 1e plus a new element. Then I don't know what that element is. We are going to find it. And also plus energy must be released. So this energy that is released is what is harnessed by human beings for whatever. Now let's find what that's, even though it's already here, let's prove how it became 230 and 90. Now remember, atomic mass of that new element, what will happen? Remember, this is 4 and another 4, because this 2 is telling us that it happens twice. So 4 was given out before, another 4 is given us. Therefore, I'm going to say 230 minus 8. 4 plus 4 is 8. 238 minus 8 is going to be 230. So the new element formed is going to have atomic mass of 230. Remember, this is 0. 0 plus 230 is still going to be 230. So we keep going. Now, coming to the atomic number part, we now have, this is 2 plus another 2, which is what? 4. So 92, this is 92 minus 4, right? Okay, I'm not adding because something else happened here. Now, it also gave off 2 of this beta particle. So this is 2, 2. Then this is going to be minus 4. Then we have to find this first. So 92 minus 4 is going to be 88. Now this 88, something happened. Remember, it's going to be addition. like we said in the last one, we are going to be adding these two. So this is going to be plus 2, which is going to give us 90. So this is going to be 90. This is going to be TH plus the energy given off. So this is what happens when radioactivity happens. When radioactivity happens in terms of its nuclear reaction. Now, artificial type of radioactivity is that when known radioactive element is made radioactive by bombarding it with radioactive particles, usually alpha, proton, or neutron. Now look at this. This is that neutron. The neutron, like I was talking about, the neutron is given as this. This is the neutron. And each time it hits any element, be it natural radioactive substance or non-radioactive substance, it will surely go into disintegration. And that is why, and it's very, very effective in doing it. As you can see on this video, it hits this uranium and many other kinds were produced on the process. Now looking at this, this one hits 235, produces barium, krypton, and 3 more are produced. And the more they are produced and the more they hit other kinds of elements, they keep generating. Like I said before, this is what gave birth to the atomic bombing that we are talking about. And that is why the world is very careful, keep on checking on different countries, having policies in order to checkmate the use of nuclear energy in different countries. All right, so we have examples of artificial. The neutron, the proton, and the alpha particles have been found to be very effective bombarding projectiles for disintegrating the nuclei of element. For example, this is magnesium. When you bombard it with this neutron, it gives off sodium and then produces proton. This is proton, and a release of heavy energy. Then this one is also beryllium and produces, when it is hit by proton, it gives off lithium, and alpha particle is produced plus the release of energy. This is also another kind of radioactivity, which is artificial kind. Now, on this note, this is radioactivity, which is naturally mankind has to produce other kinds of radioactivity, which has given birth to what is called nuclear reaction. Nuclear reactions are reactions in which one or more nuclei are produced from a collision between 2 nuclei or 1 nucleus of and atomic, subatomic particles. So there are 2 types of nuclear reaction. We have fission and fusion. Fission, looking at this, of course, looking at them, you should know what has happened. When 2 or more nuclei form together, we call it fusion. And when they break apart, we call it fission. Now looking at this one, this is deuterium and this is tritium. When they join together, we have fusion. They join together. And this is exactly also what happened in the other one we've seen. Looking at this one. And this is really what has happened in the production of sun. You know, when you look at the sun, and mankind has found it, they have produced everything. It's not sun. We have not really been able to produce sun because of the high temperature needed for that effect. So when we also look at the fission, is the breakdown or splitting up of nucleus of heavy element into smaller parts with release of huge amount of energy and neutron. Now look at this. This is what fission is all about. I've explained how these things work. I say this is the neutron and uranium. You produce barium, krypton, and more neutron plus energy is released in the process of fission. So whenever there is fission, more energy is released. Now, we have looked at this also. Okay, looking at the fission, like I said, if you want to know the common principle that guides the sun and the energy which is generated on the process is you have to go and study fusion. Then this is 2 hydrogen isotope forming this kind of helium, another isotope of helium, and the release of neutron and heavy energy produced on the process, and something happens here. Use of nuclear energy. They are used to generate electricity. Of course, electricity is used. Electricity in some countries that have really harnessed nuclear energy, they have no issue when it comes to electricity. Then they are used for radiotherapy in medical field. They are used as radioactive tracers and preservative in agriculture. They also used as fuel in ship and submarines. Nigeria nuclear energy program. One of the major problems besetting the Nigerian economy is insufficient power generation. Indeed, for a country with a population of over 140 million people, even now we are saying it's about 200 million. Nigerian grid capacity is only 6,000 megawatts, which pales in comparison, for instance, with South Africa, a country with 44 million people, yet with a grid capacity of 46,000. So, looking at this kind of energy that nuclear energy can produce, I think it is something of a great importance that we can start generating and also investing on nuclear power. Then to address this problem, the Nigerian National Atomic Energy Commission, which is NECO, has proposed to generate at least 1,000 megawatts through nuclear power in 2017. Meanwhile, the International Atomic Energy Agency has satisfied Nigeria as having met the first requirement set by the agency, and up to date, we are still doing our normal thing, trying to find our footing on the programs the country has set and its agencies to address this problem of poor power generation. The challenges, however, include the handling of radioactive materials, the safety and security of these materials, inadequate trained staff that can handle this, of course. And that means in our budget, I don't think a lot of attention has given to this effect on our budget in taking care of this, when budget is mainly given out for some unsubstantiated issues. However, our major problem with this energy problem is, remember, in this radioactivity there is a lot of, it can cause cell mutation, transmutation, so it can destroy cells. Therefore, trained staff and materials, they can be used in order to prevent the effect that will be coming when nuclear energy is given out, like environmental hazard and the death due to its effect is something Nigerian government is afraid of, because they are not yet ready for that. And that has come to the end of this lesson. However, we are going to solve a few more problems that relates to nuclear energy in our Examguide app. Okay, we say a nitrogen nucleus bombarded with alpha particles produces an oxygen nucleus and proton. The nuclear reaction for this process is this. Which of the following statement about the reaction is not correct? Which one is not correct? Okay, we are going to write it down and analyze what the equation is all about. So I have this. So plus okay. Now looking at this, we have, let's first check if it is complete. This plus this is going to give me 18. So atomic mass, this plus this is 18. This plus this is also 18. That is correct. This plus this is 10. And this plus this is not complete. So something is missing here. We can only balance it. This is not complete. This plus this is 9. But that's not it. Let's look at what the question said. It is an induced nuclear reaction, greater proton number. It is an induced nuclear reaction, with greater proton number. Greater proton number, how? Nitrogen was bombarded with alpha particle. Greater proton number, no. There is no proton number that is greater because this is 8 and still this is 8. Therefore, this is not correct. Now, the sum of the initial nucleon number is equal to the sum of the final nucleon number. Of course, nucleon number is talking about the atomic mass. This plus this is the same thing as this plus this. So the sum of the nucleon number must be equal to the sum of the nucleon number on the other part of the equation. Yes, that should be 3. And this is one of the laws of nuclear reaction. It is a natural radioactive decay. Is it natural? No. It cannot be natural because they said it is bombarded, and this is called artificial process. So this is also not true. A bombardment results into a nucleus with a greater proton number. No, the proton number is not greater. It is equal. Therefore, this question has where I can say that they say which of these statements is not correct. Therefore, this is not correct because there is no greater proton number. Proton number is this one. There's no greater proton number. The same thing now, it is an induced nuclear reaction. Greater proton number. This is also not true. All right, we'll go to the next question. Now we say a nuclide 2O2 of 84 emits in succession alpha particle and a beta particle. The atomic number of the resultant or resulting nuclide is. All right, let's look at this. 2O2 and 84. All right, when it gives off alpha particle, when it gives us alpha particle, that is going to be 4, 2. Then, and the same time, is giving beta particle. So, what element is going to be formed? All right, the mass number is going to be 202 minus this is going to be 198. Yes, 198 is there. So, this is going to be 198. Yes, it's going to be 198. Is there any information on the atomic number? There's no information. So, the answer is D. I'm choosing D as my option. Okay, we looked at this. Say a beam consisting of an alpha, beta, and gamma ray pass through a magnetic field at right angle to the direction of the field. Okay? Which of the following observation would be made about the alpha, beta, and gamma? All right. Deflected, not deflected, deflected. Okay, alpha is going to be deflected, beta not deflected. That's not true. Beta must be deflected. Alpha not deflected is not possible. Alpha must be deflected. Alpha deflected, beta deflected, gamma not deflected. This is the correct option because alpha must be deflected because it's a positive charge. Beta must be deflected because it's a negative charge. And then gamma does not have charge, so it should not. Okay, uranium of atomic number 92 and mass number 238 emits alpha particle from its nucleus. The new nucleus formed has respectively atomic number and mass number. So if this is 2, 3, 4 should be left. Where is 2, 3, 4? Okay, yes, 2, 3, 4 is here. And it was 92 minus 2 is going to be 90. So this is the correct option. 2, 3, 4, and 90. That's correct. Finally, one more question. The number of protons in the element increased by 1 after a radioactive decay. The element must have decayed by emitting beta. It is beta that will increase. If the proton number increases by 1, that means 1 beta particle must have been emitted. Thank you for being part of the class.